Okay guys, so what we're going to be doing now is section 8.5 log laws. At the end of this section you'll obviously have an awareness of the 6 log laws, and you'll be able to use these log laws to simplify complicated expressions. So I'm going to run through the 6 log laws and just explain how the log laws work. Basically in the yellow boxes are the log laws themselves, and I'll be speaking about those. And on the right hand side is a proof or a justification of why those log laws are true. I'm not going to run through that. I'll let you do that yourself, but it is well and truly worth looking at that through your notes as you go along. So just pause this video as you go after I explain each log law and try and understand how each log law was formed, because if you do that, you will be more likely to remember these log laws. Okay, so to begin with, log base A of m times n equals log base A of m plus log base A of n. So all this means is that log of any base of the number m times n, then all you need to do is log of that same base of m separately plus log of that same base of n separately and add the two together. So when you see m times n, then you can do an addition. So notice that it's log base A in each, and here we're adding, and there we're multiplying. So an example could be log base 3 of 12. So 12 could be broken into 6 times 2. So log base 3 of the number 12 is equal to log base 3 of 6 plus log base 3 of number 2. Hopefully that makes sense to you. I suggest you maybe even write that down underneath as an example. Here we've got log base A of m divided by n. So we can rewrite that as being log base A of m take away log base A of n. So here we've got m divided by n, and if we treat it separately, then it's log base A of m minus log base A of n. And of course, if you see that written there of the same basis and we go subtraction, then you can simplify it and put it into this format. So they work both ways. Third log law, log base A of m to the power of n. Then what can happen here is that that power just gets taken to the front. And you can see that there. So instead of having it m to the power of n, the n goes to the front here. So now it's n multiplied by log base A of the number m. Okay, this fourth log law is a little bit different, but we've got log base A of number b. Now, what we can do is rewrite it as this fraction. Notice that we've got our b here and our a there. So if we take log base of something that's different than a, if we take log base of p of the number b, where b is this, and then divide it by log base p of number a, where a is the base of the original stuff on the left hand side, then those two parts will be equal. So it's just a rearrangement there. The fifth log law, log base a of number 1 is equal to 0. So log of any base of the number 1 will always spit out a 0. Log base a of 1 on m is the same thing as minus log base a of m. And just some other properties that we have. Log base a of a to the power of n will just be equal to n. So if you've got log base a and you've got that same number there to the power of n, just n. So as an example, if we had log base 10 of the number 10 raised to the power of 4, then the answer for that would be just 4. So if you like, the a parts here cancel each other out. Similar kind of idea here. If we have a raised to the power of log of a of b, the result will be just b. So an easiest way of thinking about this is just the a's parts will cancel, just to leave you with this. Alright, so let's look at some applications. I know, not quite yet. Let's rewrite this index form into log form, and we're using that identity here. So 2 to the power of 5 is equal to 64. So log base 2 of the number 64 is equal to 5. Log base 5 of 625 equaling 4 in indicial form. So log base 5 of 625 is equal to 4. I'm looking at the application of log laws now to simplify various expressions. So the first one here for A, we've got log base 10 of the number 6 plus log base 10 of the number 4. Notice that the logs both have to the base 10. So what we're able to do there is simply multiply what's inside the brackets together because we have an addition. So it's log base 10 of 6 times 4, which now becomes log base 10 of 24, which is one of the first log laws. In B, we've got log base 3 of the number 81. So hopefully you'll get a feeling there that that number 81 could be rewritten as 3 to the power of something. So now I've got log base 3 of 3 to the power of 4. With my log laws, I can take that 4 and take it out the front. So now I have log base 3 of the number 3. And if you've got log base of anything of that same anything, then it will simplify to being 1. So in our case, we've got log base 3 of the number 3. This lot here will just become 1. So it's 4 times 1, which is equivalent to 4. For C, we've got log base 2 of 12 plus log base 2 of 8 minus log base 2 of 3. So we're going to be making use of the first and second log laws here. So where we've got addition, we can take what's inside the brackets and multiply. And then when we've got a subtraction, we can do a division. And we can only do this for where the bases are all the same, and these are all the same. So log base 2 of 12 times 8 divided by 3. That will simplify to being 32. And now the 32, hopefully you'll recognise, can be rewritten as 2 to the power of something. So it's log base 2 of 2 to the power of 5. And we'll have that 5 can come down as well. So it's 5 lots of log base 2 of 2. And of course, because we've got log base 2 of 2, that will just simplify to being 1. So it's equivalent to 5. So we go from what's really complicated here to something that's really simple. D, so we've got an addition, got the same bases here, so we should be able to do something with this. But first of all, what we're going to do is rewrite these so that they have, well, in my first example here, on my first move, I've rewritten that 8, so it's 2 to the power 3. And on the right hand side here, I've done nothing at this stage. So moving on, that 3 can come down, so it's 3 times 2 multiplied by log base 2 of 2 plus 3 log base 2 of 3. 3 times 2 is 6. Log base 2 of number 2 is 1. And then I've still got my right hand side. 6 times 1, of course, is just the 6. So this is equivalent to 6 plus 3 log base 2 of 3. E, I've got log base 10 in both of these terms. And I've got 2 lots, and you can see I've now got some algebra involved, x plus 3 and x minus 2. First of all, let's bring the 2 up to the top. So I've got log base 10 of x plus 3 squared minus log base 10 of x minus 2. Same bases, so log base 10 of x plus 3 squared, and because of the minus, I'll do a division, x minus 2. f, a third of log base 2 of 64 plus log base 2 of 5. So the 64 I rewrite as being 2 to the power of 6 in my next line of working here. With that power, I can take it down the front. So it's 6 times 1/3 log base 2 of 2 plus log base 2 to the 5. 6 times 1/3 is 2. Log base 2 of 2 is just 1. And I end up with 2 plus log base 2 of 5. That's one answer. Let's take a look at an alternate approach. Here I've got 1/3 of log base 2 of 64 plus log base 2 of 5. So obviously these bases are the same. In my first move, I'm just going to bring up the 1/3. So I've got log base 2 of 2 to the power of 6, all raised to the power of 1/3, plus log base 2 of 5. 6 times 1/3, just using index laws, becomes squared. So I have log base 2 of 2 plus log base 2 of 5. The 2 squared, of course, is 4. So there's my 4, log base 2 of 4 plus log base 2 of 5. So because these are the same log bases and I'm adding, then I can just say it's log base 2 of 4 times 5, which is log base 2 of 20. So you can see that both of these answers are correct, but they're both a little bit different. And of course, you need to have an awareness of this, because you could be asked to say, we've been given this expression in a multi-choice question, and you have to nominate which one is the correct answer. And so you might originally come up with this, but you have to have an understanding that you could rearrange it so it gets into this format, and that might be option E as an example. Let's now take a quick look at our CAS calculator and see what the CAS spits out for this particular one. So here's my CAS. I wanted a fraction, so it was fraction 1/3 being multiplied by log base 2, so control down here, log base 2 of 64 plus log base 2 of 5. Hit enter, and here my answer is log base 2 of 5 plus 2, which is the first option I had. Okay, looking at G. Again, a lot of algebra involved with this, with x's and so on, but it's the same kind of approach. You can see that all of these terms involve log base 2, so I'll be able to use that addition and subtraction laws. So to begin with, let's put the number that's out the front to the power, so log base 2 of x to the power 3 minus log base 2 of x plus 3 all raised to the power of 4, so that 4's just gone up here, and then that stays the same, log base 2 of y. I've got a subtraction to begin with, and these both involve x's, and it's log base 2, so I can rewrite that as being log base 2 of x cubed divided by x plus 3 to the power of 4. So that second part. And now I'm still adding log base 2 of y, so that's just come down. Now finally, because we've got an addition of these two terms and they're involving log base 2, then I can just simply take the first bracket and multiply it by the second bracket inside for that log base 2. So it's log base 2 of x cubed over x plus 3 raised to the power of 4 being multiplied by y, which is this format here, just a little y on the top line of that fraction. Okay, finally for h, 2 lots of log base 5 of the square root of x minus log base 5 of 5x. In my first line of workings, I recognise that x, the square root of x, is the same thing as x to the power of a half. And with that 2, I just brought it to the top. And the right hand term stays the same. Of course, x to the power of half all raised to the power of 2 just becomes x to the power of 1. And I've got myself a subtraction. So I can rewrite that as being log base 5 of x over 5x. Of course, the x's cancel. So I now have log base 5 of 1/5. I can rewrite this so that the 5 is at the top of the fraction, but that just means I need to change the sign of the power. So instead of being 5 to the power of 1, it's now 5 to the power of -1. The -1 can come down the front of the log. So it's -1 multiplied by log base 5 of 5. And of course, log base 5 of 5 can simplify to being 1. So now we have -1 times 1, which is just -1. So all of that, which looks really complicated, is just equal to -1.